Okay.
So the question number 15, which is, let's try this one, and then we will be trying the question number 21. So question number 15 is, integration of ln x whole square dx. So the first step is we have to identify what is our u and what is our dv. So let's take, we don't have any other option to take dv instead of a dv as dx, because we have to take u as ln x. Another option that is left is dv, which is dx. There's only one function. We don't have any choice. So du is the derivative of ln x is 1 over x dx, and the integral of dv is x. Applying the integration by parts formula, which is,
It's not ln x whole square.
oh yes, ln x whole square. So it will become power first and minus 1 from the power. So it is 2 ln x, and the derivative of ln x, which is 1 over x. So it becomes du is equals to it is 1 over x. So it is 2 ln x over x dx. The formula for integration is uv minus integral of v du. So u is ln x whole square, v is x minus integral of v, which is 2 ln x over x, and du is x, and there is dx of 2 ln du. So it becomes x ln x whole square minus, can we cancel out x on both sides of the equation, or on from the numerator and denominator? And
Yes.
taking the 2 outside, so it becomes ln x dx, and we know that integral of ln x is
1 over x.
the integral of ln x is 1 over x
Yes.
plus c. So let me check the answer. I think that's the correct one.
What about the dx?
Dx, wait 1 minute. there are again two functions. We can't just say that the derivative of ln x is 1x, 1 over x. So we have to take again the by parts. Now u is ln x and dv is dx. So du becomes 1 over x dx and integral of dv is v equals to x. Is it clear?
Yeah. So we did it again.
Yes, we have to do it again because there are two functions again. X ln x whole square minus 2 u is ln x, v is x minus integral of v du, which is 1 over x dx. So it becomes x ln x whole square minus 2x ln x minus x is cancel out minus dx.
What about the 2 minus 2?
Yeah, the 2 is multiplied with the whole. So 2 is
Okay.
multiplied
So
with this.
it shouldn't be plus 2?
Yes, it's gonna be minus plus 2. Yes.
Okay.
And it's gonna be x plus c. Is it clear?
Yes.
X ln square x minus 2x ln x plus, yeah, that's the correct answer. Okay, now let's move on to another question, which was question number 21. Here there are three functions, which is x, e raised to the power 2x, and 1 plus 2x squared. And these functions are multiplying and dividing. So let's solve this question. Is integration by parts easier for you now?
Yeah, it's easier. But sometimes I get confused with like when we have to do 2 or more times the integration.
Yeah.
But this one it was okay. But then there was another question, if you remember last week. It was sine. I don't remember the question. But
Okay,
it was sine x dx. That one I was until now I'm so confused with it.
it was an example question or an exercise question?
It was an example question. I'll tell you the question right over this. 1 second. It is e to the x sine x dx.
Oh, that's example number 4. Okay. Should we do it now again, or let's continue with question number 21?
We'll continue and then we'll go back.
Okay. Question number 21 is x e 2x 1 plus 2x whole square dx. Okay. So we now have to identify what is our u and what is our e, or what is our dv. So can I write my function something like this? Like in a separate form, xc2x separately and 1 over 1 plus 2x square separately. So I can say that this is my u and this is my dv. Is it clear now? Okay. Your next step is to identify what is our u and what is our dv. U is x e2x and dv is 1 over 1 plus 2x whole square dx. Why we chose dv as 1 over 1 plus 2x? Because I can't choose u as 1 over 1 plus 2x squared, because when I differentiated it, it's gonna be
Can you repeat this question? My internet, I don't know, like suddenly you're writing that question and then it skipped. So can you please repeat?
oh yeah, sure. We are actually doing question number 21, which is x e raised to the 2x over 1 plus 2x whole square. I
Okay.
just wrote my function in this form separately, like numerator and denominator separately. So x e2x multiplied with 1 over 1 plus 2x whole square dx. Now my next step is to identify what is my u and what's my dv. U, I chose my u as x multiplied with e raised to the power 2x and dv as 1 over 1 plus 2x whole square dx. Now, why I chose dv as 1 over 1 plus 2x whole square? Because in the u, we need a function that is reducible, like its power is reducible from x square to x and x to constant. But here, if I differentiate it, can I write this function something like this? 1 plus 2x in the negative power.
Okay.
Yeah,
It's
yes.
going to be long.
Yes, then power first, and the minus 1 from the power is gonna be 1 plus 2x minus 3. And then again, if I differentiate this, it's gonna be 2. So minus 4 over 1 plus 2x cubed. So the power from 1 plus 2x whole square to 1 plus 2x whole cube, it has actually increased. So it's if I differentiate it again, it's gonna be power 4, power 5, power 5, power 6. The function is not reducible, it is increasing in the power. So I can't choose a function u as my 1 over 1 plus 2x whole square. Is it clear? Okay. Even if you choose u as this function, you after applying integration by parts, once you will realize that this function is going to be complicated. Let's try it another way, and that other way it's going to be easier for you, but you have to be very quick in the exam. Okay, so I was at our u function is the multiplication of x and e raised to the power 2x. It means we have to apply a product rule here to differentiate it. So du is equals to, did you remember the power rule of differentiation? Oh, I mean the product rule of differentiation.
Which one is it? I don't know the names.
The product rule. I mean when two functions are multiplying.
Yeah, it's
yeah.
fx equals f
X
prime g plus g prime x.
Yes. So keeping x as it is and differentiating e raised to the power 2x, so it becomes e raised to the power 2x multiplied by 2, because I am differentiating it again, then plus sign of the formula, and then keeping e to x as it is and differentiating x, so it becomes 1, and then there is dx. So du is equals to 2x e raised to the power 2x plus e to x dx. Is it clear? Okay. Now we have to find out our dv, which is v equals to 1 plus 2x minus 2 integral. Can I write my function as the negative power? Then we have to apply the power rule. So it becomes 1 plus 2x minus 2 plus 1 divided by minus 2 plus 1. So it becomes minus 1 and 1 plus 2x minus 1. One over 1 plus 2x minus 1. So I got my v du u. Now we're going to apply the integration by parts, which is u v minus integral of v du. So u is x e to x. V is minus 1 over 1 plus 2x minus integral of v, which is minus 1 over 1 plus 2x, and du, which is 2x e raised to the power 2x plus e raised to the power 2x dx. So it becomes x e raised to the power 2x divided by 1 plus 2x minus minus plus minus by minus, and minus becomes plus. So 1 over 1 plus 2x. Can I take something common from this function, from this expression? E to x, that can be taken common, and inside is left 2x plus 1.
Yes.
2x plus 1 can be cancelled out with 1 plus 2x. So it's left only minus x e raised to the power 2x divided by 1 plus 2x whole plus sign and e 2x over 1 plus 2x. Again, we have to apply integration by parts. Oh, 1 minute. This 1 plus 2x and this 1 plus 2x was cancelled out. So only thing was left was e 2x dx. Clear? Is it clear?
Yeah, it's clear.
Okay. Now taking its integral, it becomes e raised to the power 2x and d by dx of 2x plus c. So it becomes minus x e raised to the power 2x over 1 plus 2x plus e 2x over 2 plus c. That's the answer. Is it clear?
Okay. Yes.
If you want me to do any other question, then we can do it. Otherwise, we are going to shift towards the example question.
Okay, we'll shift.
Okay, let's do this example, which is ex, integration of ex sin x dx. Integral of ex sin x dx. Okay, the concept behind was that both of the functions are irreducible function. When differentiating, it's gonna be ex again gonna be ex, and sine gonna be cos x, cos gonna be minus sine x. So both functions are irreducible in terms of power. So whichever function we choose, whichever function we can choose for u and v.
This is the other type or the same type?
I didn't get your question. Can you please repeat it again?
Is this the integration by substitution or the by parts?
Is it integration by parts?
Okay.
Yeah. We are actually doing example number 4. Okay, now let's take u as ex and dv as sin x dx. Okay, so du becomes ex dx, and integral of dv becomes v, and integral of sin x will becomes minus cos x. So uv minus integral of v du. U is ex, v is minus cos x, minus integral of v, which is minus cos x, and du, which is ex dx. So it is minus ex cos x, minus minus becomes plus, integral of ex cos x plus, ex cos x dx. And here we have ex sin x dx. Here you have again two functions. We have to apply the integration by parts again.
Okay.
Okay, so it's gonna be u is ex and dv is cos x. So cos x dx. So du becomes ex again, and dv becomes sin x.
That's
So,
ex dx, right?
Where?
For the EU. Ex, I mean. The du.
Yeah. It's only ex dx. Yes.
Okay.
So it is uv ex multiplied with sin x minus integral of v, which is sin x, and du is ex dx. Okay, now we realize that we have come back to our question. Like in the answer we have got the question. So can we shift our question to this side?
Yeah, the other side.
Yes, so it becomes 2 integral of ex sin x dx, and this side it will be left only minus ex cos x plus ex sin x, and dividing both sides by 2, it becomes, and we have constant of integration as well. So integral of ex sin x dx equals to minus ex cos x over 2 plus ex sin x over 2 plus c. That's the answer. Is it clear? Is it clear?
Yes. Yeah.
Okay. We can also
We
choose
don't
like,
have to simplify like half e. Like, can you go down, please?
yeah, sure.
And the earlier question, the one I asked you about sin x, this is the same question.
Yes.
We did minus half ex. We don't have to do this again.
Can you use your marker to highlight it? Which point, which part you are asking about?
Okay, 1 second. I'm looking for a marker. Okay. Last time we did here minus 1/2 ex cosine x. This was the answer to this one. Why this time we only left it like this? We didn't do it this way.
Last time we got this answer completely, right?
Yeah, and then we went further down to this.
Okay. I think I simplified it further, like by taking half ex common. So it was only left cos x minus sin x plus inside. I think we simplified it last time.
Yeah, why didn't we do this again this time?
That's the answer to this part. I mean, the answer till now is acceptable. If you want to further simplify, yeah, we can do. Both the answers are acceptable.
Okay.
Yeah. Is it clear?
Yes.
Okay. Oh yeah, I was telling something else. So can you try this example number 4? Now using u as sin x and dv as ex dx.
Okay. This is the same question I asked you about, right, earlier?
Yes.
Okay, so du. Okay, and then v. Okay, so du will be cosine x, right?
Yes.
And then v will be cosine x dx, and then v will be ex as it is. So then we have to use uv minus the integral of v du. So it's gonna be sine x ex minus ex cos x dx. Okay. Here we have to do it again 2 times integration, right?
Yes.
Okay. So we. Okay, wait. So to get from u to du, we have to integrate. We have to do derivative, right?
Yes.
Okay, and then from
dv to v, we have to integrate it.
Okay, so here I have v as cosine x. Okay, the next step. So dv will be minus sign, right?
dv will be minus sign? No. See. When my screen is shared with you. Yes. So I took my u as sin x and I took my dv as ex dx now. So to get u to du, I have to differentiate the function. So it becomes cos x dx.
Okay.
Okay. And from dv to v, I have to integrate it. So it becomes v equals to ex.
Okay.
Okay. Now I have to apply uv minus integral of v du.
Yeah, so it's gonna be sine multiplied by ex plus ex cosine dx, cosine x dx.
Okay.
Okay, and then for this part, for this part, we have to do again integration, right?
Yes, we have to again apply the integration.
Okay, so it will be u will be ex, and then v will be cosine x dx, and then du, and then dv. So this will be ax as it is, and this one here, it will be cosine x, right? I mean sine x.
Yes, it will be sin x.
Sine x. Okay, so now we just substitute again. So it's gonna be sine x ex minus again we have to do it again. Right? I'm doing it right?
No.
Okay.
If you can erase ex as well, let it be. Okay. Then it should be again uv was u is ex and v is cos x dx. Then again minus integral of, because our formula is uv minus integral of vt. Okay, so uv minus integral of v is cos x dx and du is sine. This is u, this is u, and this is du, and dv should be sine x dx. Okay, so from it should be sine x cos x. It should be only cos x here.
Okay.
And our du is ex.
Okay.
Okay, 1 minute. I'm thinking, I think we have to take the differentiate again, or I mean integral again, if we are doing this way. Let me just check it out. If I'm taking u as sine x and then v as dv as ex dx, then my du is gonna be cos x dx, and then my dv v is gonna be ex. Okay, so uv is sine x dx minus oh. Let's apply the integration here again. So u is cos x dx, cos x, and dv is ex dx.
This is for which part?
We are going to, yes, no, for this one. I think we have made a mistake here. So I'm going to apply the integration again here.
Okay, can we start, because there's so much things that I'm getting confused. Can we like do it again from the beginning?
Okay. Should I erase it also?
Yes, please. Okay, now, okay.
In the previous parts, we were taking u as sine x. Now we are, because we know that both functions are irreducible. So we can take whichever u and whichever dv. In the first part, I did u as sine x. Now in this second time, when I'm taking u as sine x and dv as ex dx. Okay, so from u to du, I have to differentiate it. So it becomes sine x cos x or cos x dx.
Okay.
From dv to v, I have to integrate it. So ex.
Dx.
Okay.
Okay.
Applying the integration by parts formula, it becomes uv minus integral of v du. So my u is sine x, my v is ex, minus integral of v, which is ex, and v u, which is my cos x dx. Is it clear so far?
Yes.
Okay. Again, we have two functions now. We have to apply the integration by parts here. So my u is cos x, and my dv is my ex dx.
Doesn't matter, right? Even if we take the opposite, doesn't matter, right?
Yeah, if you, because in the first time I took when I was differentiating, integrating it again, I choose u as ex. This time I want to do it opposite. I want to do u as cos x.
Okay.
So du is equals to minus sine x dx, not dx. Yes, dx. And then integrating it again, it becomes v equals to ex. So again, applying the integration by parts, sine x ex as it is, minus uv minus integral of v du, applying the integration by parts here. So my u is cos x, my v is ex, and my integral of v is ex, and du is minus sine x dx. Is it clear?
Yes.
And here I have ex sine x dx. So it is sine x ex minus cos x ex. This minus becomes plus, and this minus we have three minus, so it remains minus ex sine x dx. Is it clear?
Yes.
Okay.
This is what is this? This is integral or bracket?
This is bracket.
Oh, okay.
Yeah. So taking ex that side of the equation, because we are getting the same question again in the answer. Okay, so it becomes 2 integral of ex sine x dx equals to sine x ex minus cos x ex, and dividing both sides by 2, so it becomes ex sine x dx equals to half ex common, and side is left, sine x minus cos x plus 6. This is the answer. Is it clear? Both way we have got the same answer.
Yes, clear.
We have only 15 minutes left. Okay, let's shift towards the U-substitution.
What is this U-substitution?
This is U-substitution. In the U-substitution, we can, this is another type of applying the, this is another way to find out the integral of a function, just like
Okay, so the part was by parts, and this is by substitution, right?
Yes, this is by U-substitution. U-substitution is more easier than integration, than by integral by parts, because
Okay.
we can apply U-substitution only that time on the functions if its derivative is there. If the function and its derivative is there, then there is point to apply the U substitution. Otherwise, it's gonna be hard. So I got some questions from, I think your friends Hamdas and me. So we are going to solve those questions.
Okay.
So the example number 1 is find out E6x dx. Okay, so let's take our U as 6x and we'll be differentiating this function. So it becomes du is equals to 6 constant and the derivative of x is 1. So it becomes 6 dx. Okay, now applying this into this original equation. So it becomes integral.
There is no v?
No, there is no v.
Okay, so in this type of integration, there is only u and du, right?
Yes. Du
Okay,
is the
how do you know
derivative.
which one we take?
Sorry?
How do you know what to take? Like, why didn't we take e?
Why didn't we take, I didn't get your question.
Like, in this type of questions, how do we know which number or which constant to take as u?
Okay, so okay, du 6x, can I use u as 6x? Okay, and I'm coming back to your question again. So dx is du over dx is equals to du over 6. So can, instead of ds, can I write du over 6? And taking 1 over 6 common because that is constant, and inside is left eu du.
Okay.
Okay, and now it's easier for me to apply the integration here because I know what is the integral of eu, which is itself eu plus c. Is it clear?
Yes.
And 1 over 6 eu is I have to substitute back now u. What was our u? U was 6x plus c. That is the answer. Now your question was that why should I choose 6x as u? Because if I choose the whole as u, okay, and when I differentiate it, it's gonna be p6x as it is, and then taking the derivative of it, it becomes 6. So it's gonna be 6e6x dx, and now my dx is du over 6e6x, right? And when I substitute this into this function, it becomes, instead of e6x, can I write u? And instead of dx, I have to write du over 6e6x. So if I need in the u substitution, when I'm applying the u substitution, I need only u stuff here, the function in terms of u only. Here, when I substitute e6x, I got the function in terms of u and x as well. When I chose e equals 6x as u, my function was completely in the form of u, not in the form of x and u combined. Is it clear? Even if we want, we can apply, like, but that's gonna be more complicated. Du instead of e6x, can I write u 6u? U is cancelled out, and taking 1 over 6 outside, inside is left only du, and we know the integral of du, which is u plus c, right? And our u was e6x plus c. So both we have got the same answer. We can choose it. But this question was simpler because this question has no derivative of e6x or 6x. In the next question, when we applying the U substitution, you will be see when we are differentiating the function, the derivative of the function is there inside the function. So we have to choose that wisely. Okay, let's do another question and I will explain you it further. But this question is clear to you? Okay. The question number 2 is 1 to e integral from 1 to e ln x over x dx. So let's take u as ln x, because when I differentiate it, the derivative of ln x is 1 over x dx, right? So can I write my function something like this? 1 to e ln x 1 over x dx. Is it clear so far?
Yes.
Okay. So when I differentiated it again, I got the derivative of a function which is 1 over dx, which is inside the function here.
Yeah.
So 1 to e ln x was u, and 1 over x dx is du. Now it's easier for me to apply the integration here because I know what is the integral of u.
Okay. Okay.
Okay, can I write it back? Okay, 1 minute. This limit and this limit are both for x1 and x2, but I have my function in terms of u, so I need the limits here in terms of u1, u2, and u1 form. So my original function was u equals to ln x. To get u1, I have to write ln x1. So my u1 is ln x1 is 1 and ln 1 is 0. So my lower limit is 0 and my upper limit is x2 is e, and we know that what is ln e is 1. So I have got my lower and upper limit in terms of u. So it becomes 0 to 1 u du. Is it clear?
Yeah.
Okay. And the derivative of u is u square over 2 integral from 0 to 1. So it becomes 1 square over 2 minus 0 square over 2. Upper limit minus lower limit. So it becomes 1 over 2. That's the answer. Is it clear? Okay, in this question, I can't choose u as my 1 over x because u equals to 1 over x is never gonna give me, upon differentiating, I'll be getting x minus 1. I will be getting minus 1 over x square. And the differential of du is not there inside the function. So I can't choose du as, u as 1 over x. The wisest decision will be to choose u as ln x because the derivative of ln x is there inside the question. So I can replace it with du. Is it clear?
Yeah.
Okay. Let's do another question. It is 1 plus x square x5 dx. Okay. Let's take my u as 1 plus x square, and my du will become 2x dx. But I need 1 plus x square. Can I break down x5 as x4 times x dx? Because I know x dx equals to du over 2. So I can replace x dx with du over 2. And 1 plus x square with u. So only thing I need to replace here is x4. Okay, now instead of 1 plus x square, can I write u? And x dx, can I write du over 2? Now what should I need my x4 in terms of u, so I can replace it here. Can I write this function as x square is equals to u minus 1, taking 1 that side of the equation? So it becomes x square minus x square is equals to u minus 1. To get x4, I am squaring it again. So it becomes x4 equals to u minus 1 x square. Now my x4 is in terms of u. Can I replace it? It becomes u minus 1 whole square.
Okay.
So it is square root u. We can apply here formula a minus b whole square. So it becomes a square, which is u square minus 2ab, which is 2u plus 1 whole du over 2. Okay, can I take constant out and write u square root u as u half u square minus 2u plus 1 du. Now I just need to multiply it. Half u half multiplied with u square will be 5 by 2, u 5 by 2. U half multiplied with minus 2u, it will be 3 by 2 plus u half du. Now I have 3 terms. I can apply the power rule, so it becomes add power 1 to it and divide with that power. So it becomes u. If I add power 1 with 5 by 2, it becomes 7 by 2. I mean, yeah, 7 by 2 divided by 7 by 2. And 2, if I add power 1 here, so it becomes 5 by 2 divided by 5 by 2 plus u. If I add 1 power to it, so it becomes 3 by 2 divided by 3 by 2 plus c. So it becomes half. If I take 7 by 2 in the reverse order, so it becomes 2 by 7 u 7 by 2 minus 2 times 2 is 4. 4 by 5 u 5 by 2 plus 2 by 3 u 3 by 2 plus c. And then I have to replace back u with 1 plus x square. Is it clear? Even if we want, we can further simplify it by multiplying half with whole term, and 2 is cancel out. 2 is cancel out here, 2 is cancel out here. So that we can write, if we want further simplified, we can. Is the chain rule clear to you? I mean, U-substitution rule is clear to you?
Yeah, it's clear. Yeah, it's easier than the other one.
Yes, it is more easier than the by integration by parts.
Yeah.
But here you should have a clearly knowledge of the differential. I mean, the differentiation rules. Then you can choose very wisely that what should be your U, so you can get the derivative of it. Okay, let's end it here, and we'll be doing this session tomorrow at the same time.
Okay.
Bye.
Bye. Thank you.
Bye.